What's up? Continuing with day 7 of Advent of Code 2015. Day 7, some assembly required. This year, Santa brought little Bobby tables, a set of wires and bitwise logic gates. Unfortunately, little Bobby is a little under the recommended age range and he needs help assembling the circuit. Each wire has an identifier, some lowercase letters, and can carry a 16-bit signal, a number from 0 to 16 bits. A signal is provided to each wire by a gate, another wire, or some specific value. Each wire can only get a signal from one source, but can provide its signal to multiple destinations. A gate provides no signal until all of its inputs have a signal. The included instructions booklet describes how to connect the parts together x and y to z. Means to connect wires x and y with an AND gate and then connect its output to the wire z. For example, 1, 2, 3 to x means that the signal 1, 2, 3 is provided to wire x. X and y to z means the bitwise AND for wire x and wire y is provided to wire z. PL shift 2 to Q means that the value from P is left shifted by 2 and then provided to wire Q. Not E to F means that the bitwise complement of the value from wire E is provided to the wire F. Other possible gates include OR, R shift, those are the ones. If for some reason you'd like to emulate the circuit instead, almost all programming languages provide operators for these gates. For example, here's a simple circuit. Let's copy this simple circuit into here. After it is run, these are the signals on the wires. That's what we want to see after running this. In Little Bobby's kits instructions booklet provided as your puzzle input, what signal is ultimately provided to wire A? So we have our larger input here. Let's try with the example input. Let's see. So we have, let's just go instruction by instruction. So the first one, for each line in our input, we will have to split the line, add space, and then if the second one is an arrow, instruction is this, if or when, instruction 1 is this, then we know we have this kind of instruction where we assign a value to a gate. So we need a map of gates, string to int. Then if we have this, we can say give me the instruction 0 to int and store it in my map at instruction 2 space. Instruction 2 is x, instruction 0 is 1, 2, 3. Then that covers these two lines. Then we have x and y, x or y, in which case we have to look at the second instruction again. It's and. Then we want to pick the first one and the second one and the third one, and combine them to save them in the fifth one. So map at this space will have an AND of these two, but only if the instruction, well, if these variables x and y is in the map, then I can add them. And instruction 2 in m.keys. Then we can end these instructions. Otherwise, let's not do anything yet. Then we have something similar for OR. Basically the same thing, just with OR instead of AND. Then we have L shift and R shift. So if instruction 1 is L shift, we have to take the first one, L shift 2, and put it into F, or put it into instruction 4. So instruction 4 equals M instruction 0, L shifted to L shift shell. We can use this as well. Shell and shur. Shell 2. I haven't used this, so we have to test it. Let's see. Shur. Shur and shell. So if instruction 1 is not, no, actually, let's just say if instruction 0 is not, then we have not x and y, so instruction 1. So we want to put the not x in h. And also not sure to do not. Inf. One zero one one zero zero inf is 0 1 0 0 1, 1. I think that's what we want. So else unexpected. So, and we need some checks here. If in m.keys, so only if this is available, we want to run it. Then let's run this on our example input and check the output. Okay, what we want is DE. Let's just check. D is 72. That's good. E is 507. That's good. F 492. Yes. G 114. H is minus. Aha. So we kind of put a modulo in there always, I guess. Basically always. I don't know when it can happen. The highest number is this. So we do this, I guess. Let's put this everywhere and see if that fixes H. No. It happens in H, not X. Strange. So the problem is that it goes negative here. I thought that minus 1 mod 3 would be 2 or something. No, that's minus 1. Wait. What did I just do earlier? I think I have to do this, but with brackets. Yeah, now we flip it positive and then modulo it so it's in the range 65412 and 65079 and then 1 2 3 4 5 6. Okay, that works, but it works because X and Y get populated first. I'm not sure that's the case here. Let's see. First, if we get any errors. Okay. LX to A. Ah, okay, so this could also be a number. Then we have to check if instruction, let's take the first, that's a digit, then we can go for it, else we have to check instruction 0 in m.keys, we can go m at instruction 2 is m at instruction 0, because it's copying from one register to the other. Okay. Nice, it doesn't break, but we don't have much results. In Little Bobby's Kids booklet, what's the output of A? Okay, we don't even get A yet. I hope we can just loop over it. A few times so it all fills up till we get A. If not, then we have to come up with something smarter. Do we have A yet? Strange, we don't get A. I wonder if this sorts it by keys here. We know that LX get copied into A. We don't really have LX. We don't really have anything with 2 cars. We are using string, so that should work. Our operations all work because we tested them. Aha, maybe this is another case. One and U, so if one of them is a digit, then we have to do something else here. I wonder if I could test the whole string for its digit. No. Just check the first character if it's a digit. If the other one is a digit as well. Then we can do instruction for m instruction, well, well, we just take the toInt and instruction 2.toInt, they're both digits. The second one isn't a digit, then we have to check if second one is in keys, then we can use it. Instruction 0.toInt and instruct m of instruction 2. Then we have the case where else if instruction, similarly if this one is a digit, the first one is not a digit, and we have this case again the opposite way. The zeros in keys and I can use it. And I can get instruction 2 to int. And if else both are not digits, and I have to check both are in the thing, and we need to AND them. This is kind of pretty bad code, but it'll get us there. I kind of want this everywhere. Not sure if it's really necessary. Let's just add it here and here. Get a value for A. I'm really not sure if it's correct. Could be something else that's missing as well. So okay, obviously I have another bug here because I'm always L shifting by 2. I should be reading in the input, which is instruction 2. Which in this case I'm hoping that they don't L shift by register. Doesn't look like it. Let's have another look here. Different value. I wonder if this changes. Do only 100 times. That's bad. Oh no, we just don't have A yet. That's good. We don't even have A after 100 times. 1,000 times we get A. Let's see if it changes. Okay, let's try that one. I'm not 100% certain. Okay, that worked. So we were able to get through it by repeatedly filling in the registers that were available and just basically implementing the instructions. It's pretty verbose, and there's probably more concise way to do it, but yeah, it got us there. It's always a bit annoying to have to parse all these compiler instructions and have all the edge cases between. This can be a register, this can be a number, and so on and so forth. Let's go to part 2. Now take the signal you got in wire A, override wire B to that signal and reset the other wires, including wire A. What new signal is ultimately provided to wire A? So we just take this and put it in B. Like this. just run it again or what? Let's see. Oh, I did it the wrong way around. This is the number that I want in B. So now we have a new number for A. Let's check it. And that's it. Whew. A lot of parsing today. I didn't really enjoy that very much, but we got through it. So just filling in the compiler instructions bit by bit, using the nice Kotlin built-in bit functions on ints, which is really convenient. And yeah, that basically got us through it. Also, first time using shll and shr, which work like a charm here. Just shifts this value left by bit count, number of bits. Super nice. Cool. That's it for today. Thanks everyone. See you next time.